We're good to start.
Hello! Our project is on converting text to Braille. Our advisor is Professor Wade Trapp, and we are Group 3. My name is Maha Muslim.
My name is Erica Japierre.
My name is Tyon King.
My name is Sumeda Mendireta.
When going through different possible fields and options for our capstone design, we noticed that 1 in 4 adults in the U.S. have a disability. That's approximately 25%. Though that's not majority of the Americans, it's still a significant amount. Within that 25%, 2.4% of adults in the U.S. have a visual disability. Of that 2.4 percentage, there's over 1 million people in the United States who are legally considered blind. Then you have a smaller percentage, 50,000 people in the United States of America are considered both blind and deaf. Our goal is to target this audience. In addition, we also have 150,000 people total, which is triple than the previous number, people who are blind but also proficient in Braille.
Our original project was to create a small and easy to carry device. This refreshable Braille device would be connected to a touchscreen where a user could type a message using an on-screen keyboard, and that would be sent to the device. Some of the real-life applications that already exist include text messages that can be read using voiceover functions. However, this can pose an issue in noisy areas and also for those who are hearing impaired, making a text-to-speech option is not always the most optimal. Our project accommodates for these issues and provides an alternative. Currently, Braille devices for text are usually sized for laptops. With smaller versions that have the same functionality, it can then be carried around with ease and used on a day-to-day basis in a public setting. Thus, our target audience is those who suffer from blind deafness. However, since our project is in Braille, it is also applicable to those who are proficient in Braille, which is triple the population of those who have a blind deafness condition. For the breakdown of our group, we have 3 computer engineers and 1 electrical engineer. Since we have multiple disciplines, we wanted to have a project where we could incorporate both majors and areas of expertise. The way we divided the project was that Maham and Erica would work on the electrical engineering portion of the project, while Sumeda and Tyon would work on the computer portion. As a group, we would then combine them together to have a fully functioning project. The hardware component starts with a box. We decided to use RU Makerspace to laser cut art pieces. Here is a clip of our box being cut out.
Here is an image. Here are some snapshots of our Braille box and the template used for the laser cutter. Okay, so here we have our Braille box. This is our first attempt. This was made in a laser lab using the template shown on the previous slide. As you can see, it does need some work done on. For example, we need to cut an opening right here so that when we attach our linear slide and servos, we can see how everything is working before we covered it up. And when we did cover it up, we would need to drill holes for the raised dots, which would be our Braille letters. We would also need to cut the sides so we can fit in our linear slide and a hole for the wires. Okay, so this is our linear slide. This would have been positioned under our Braille box. Attached to our linear slide is 6, right now we have 3, but it would have been 6 servos. For our prototype, we were going to deal with Braille letters first. which are normally raised dots positioned 2 by 3. So it would have been 2 sets of 3s here. So then right now the servos are at 0 degrees. When it was connected to the circuit, it would be told which one should turn to 90 degrees in order to raise the dot. Once that letter is made, it will then move up. The linear slide will be powered to move up approximately 3.5 inches. So we slide up to a new set, and then it would make the next letter, telling which servos to move from either 0 to 45 or 0 to 90 or 90 to 0. And yeah.
Right now, the pin of the servo is directly connected to the Raspberry Pi and power source. Ideally, this would be all that we would need, but if we were able to test combining the hardware and software part, there would probably exist complications with signal transmission. This could be solved using a standard noise emitter. We also would probably need to add a resistor between the pins of the Raspberry Pi and the pin of each servo for the safety and stability of each equipment.
For the software component, we were between Arduino and Raspberry Pi. We ultimately chose Raspberry Pi because it includes Arduino. Furthermore, no one in our group had previously used Raspberry Pi, and there were a bunch of resources, such as open source, that was able to assist us with our learning curve. Raspberry Pi was used to transfer the text to the Braille device. We utilized grade 1 and grade 2. We utilized grade 1 of the Braille dictionary, even though there's grade 1 and grade 2, because grade 1 is more basic. Once the text was transferred, the solenoids would be raised for 6 seconds. The user has 6 seconds to fill the raised solenoids, which corresponded to one letter, before the solenoids would then move on to the next letter.
For our code, we take a sentence in from the user and then convert it into a string with no spaces. This statement is then sent to a dictionary which instructs the Braille device of which solenoids need to be raised in order to display the correct letter. As mentioned, the code right now accommodates for grade 1 in Braille, which is a letter-to-letter conversion from text to Braille. While working on this project, some of the challenges we faced include figuring out the Braille device dimensions to work with the linear gear. Additionally, we had to work together as a group to figure out how we would connect the Braille device to the Raspberry Pi through a circuit board. There was also a learning curve in understanding how the Braille language worked, as well as working with new softwares and languages. For our device, we learned to use a Raspberry Pi and learn Python in order to be able to code our program. We also learned how Braille worked and the distinction between grade 1 and grade 2 Braille. Finally, one of our other challenges was finding a material to put over the drilled holes so that when the servos reached 90 degrees, it would push up on something that let the user know that this was a raised dot apart from the rest of the dots on the board.
In addition to our normal challenges, we also have further constraints due to COVID-19. First and foremost, there was social distancing. Social distancing only neglected in allowing us to meet up as a group, but we weren't able to meet with our advisor in person. Due to timing constraints, we weren't able to have as many WebEx calls as often as we were to meet in person. Furthermore, we no longer had access to the Makerspace lab on campus. We did not have access to the power supply, and we were unable to drill holes in devices. And finally, because each component was with a different group member, we weren't able to fully get our prototype up and running.
Overall, the device remains to be not as accessible, and it's not really consumer friendly. For example, it only shows one letter at a time, and many readers may forget previous letters, especially in longer words. To solve this, we could add a lot of servos so each symbol gets their own set of 6 servos. However, the use of larger servos like this can increase the size of the box and not make it easy to carry around. So a solution that we came up with that may solve this is, instead of servos, using something like the pneumatic cylinders, which only move in a linear direction. And also to optimize how fast the reader can read, we can upgrade grade 1 Braille to grade 2 Braille, where certain common used words like is and the are shortened to only be one syllable. Thank you. Any questions?